Hello, this is Andy Schweitzer, and this is a short video on just basically our very first video of chemistry is what is chemistry. And you'll see from one of our standards here that chemistry involves chemicals. Students will be able to create names and structures for organic substances and organic chemicals. So basically chemistry involves chemicals. And in these chemicals therefore have to be represented by names and by formulas. So we have, for every chemical we're going to have a unique name that identifies that chemical. The chemical also has a unique structure. Now, chemicals also have a formula. A formula does not have to be unique to the chemical. We could have different chemicals with the same individual atoms but connected in a different way. So for example, glucose and fructose both have the same formula, but since they are different substances, they have a different structure and they have a different name, and therefore they have different chemical properties. We use organic chemistry as a way to sort of jumpstart this particular idea. Organic chemicals are in fact in your everyday life everywhere. So we see them. Everything from driving to school to heating our homes, using the gas grill. So organic chemicals have a unique properties, unique uses, but again, it's just a starting place. So, for example, the chemical involving organic compounds that we will be looking at is that of hydrocarbons. Now, the idea of the term hydrocarbon is an older term. Nowadays, I'm going to assume that a hydrocarbon is involving something that contains carbon, hydrogen, obviously, but very often could contain oxygen and nitrogen and sulfur. But for the most part, we'll deal with carbon, hydrogen, oxygen. So a more advanced type of a hydrocarbon. The simplest hydrocarbon is just one carbon. You should note from previous classes, even biology, that carbon bonds 4 times. It is going to share electrons, so it's going to do covalent bonds. We represent this sharing of electrons with a single dash standing for 2 electrons, and this is what we call a single bond. We'll get more into this as we get into bonding, but at this point, just so you know what I'm talking about, a double bond would involve 4 electrons, and therefore we call it double bond. And a triple bond would involve 6 electrons, and therefore would be called a triple. In the end, a carbon atom, can do this, can share a total of 8 electrons, or 4 bonds total. So the simplest way this can work is if we have a simple carbon in the center with a dash to a hydrogen, 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 and hydrogen. Okay? I would call this a simple structural formula. It's giving some idea of what it looks like. It's a flat picture, two-dimensional picture of a three-dimensional object, so it doesn't look exactly like this. In fact, this would appear to be flat. This chemical is by no means flat. Either way, this thing has a name, which is called methane. We do have things like common names and more chemical-based names. Sometimes those are used interchangeable. But this is the simplest hydrocarbon that we could have. And in this video here today, we're just going to be talking about very simple hydrocarbons. Now, hydrocarbons have the ability to link in chains. So this is a 2-carbon chain. and therefore each carbon can bond 4 times. And in organic chemistry, we tend to maybe be a little lazy and just draw a dash. This is called ethane. 3 carbons in a row is going to be called propane. Let's get a little more room here. Not that much. Okay. Somewhere in the middle. So we have ethane. Goodness gracious. Okay. Propane is going to be here somewhere. All right. 3 carbons. And again, an organic chemist could even get lazier and not even put the dashes on. And they're assuming that this is going to be propane. If I want to write the formula for this, I would write down C3H8. Where did I get the 8 from? Carbon bonds 4 times. 1, 2, 3, 4, 5, 6, 7, 8. This guy here would be C2H6. Methane CH4. The fourth one is butane. C4, you can see kind of a pattern going here. H10. So let's draw that out. Another way they might draw it is like this. Alright, now I'll erase that little line right there. Either way, so this is another way they might draw it. Each corner dot represents a carbon atom. And they're showing a little bit different angles here because really this is not straight. It's got a 109-degree angle between the carbons. And this is starting to show that little angle there. Either way, they're not showing the hydrogens, just showing the chain. Now the first 4 organic compounds are more historical in nature. At least their name is more historical in nature, and they're common, and we can look at the name to see why. But if we're going to look at a hydrocarbon, we want to know the what we call the base chain. So if it's got 1 carbon, we use the word meth as a prefix. If it's got 2 carbons, we use the word eth, or ethyl. I might say ethyl for each of these. Sometimes that little suffix gets dropped. We have 3 would be prop. 4 would be but. Now, in the infant stages of organic chemistry, they didn't realize things were hooked in chains. They just thought everything that had 4 carbons was butyl. Now they realize those 4 carbons can be arranged in a few different ways. But because these have been around so long, they've kept the first 4 historical names. And after 4, they flip to a more traditional, I don't know if it's Greek or if it's Latin, but it would be penta, hex for 6, 7 would be hepta, and then 8, 9, and 10 are also fairly common. 8 is octa. Number 9 is nona. And number 10 is deca. And there are above that. It's just these are the most common ones. Okay. Now, if we look at this thing, we also have this suffix. And the suffix we're using here is ane. Ane simply means all single bonds. Another way of saying this is that we have max hydrogens. This is another way of saying it is saturated. So if you have a saturated fat, it is a fat that has a long carbon chain that's maxed with hydrogens. An unsaturated fat would be one where we have a double bond in there, and therefore would be eliminating a couple of the hydrogens. So I were to have a name, let's say, for example, propane. I want to tell how long the carbon chain is, and I want to tell what's on the carbon chain. This thing is a 3-carbon chain, and it contains only single bonds. What I've talked about here is very much just the general basics of giving a chemical a name. And chemistry, that is really all of it. We tell how long the chains are and where things are located on the chains. For this, I'm going to just kind of add one more small bit here. Okay, and this is going to be involving double and triple bonds. So I'll just write up here, let's show the difference between single bonds, double bonds, and triple bonds. So again, we want to tell how long our chain is and where things are located. So I could have, for example, a substance that looks like this: carbon, double bond, carbon. Let's go double bond. Let's go a couple different chemicals here, and let's go one that's even longer yet. I can squeeze it in right here. Carbon, 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 and we'll put the double bond right here. So this guy here, again, there are hydrogens. I'm going back to the ethane here, this guy. There are hydrogens on here. Hard to see my pointer at times. And because carbon bonds 4 times, it'd be 1, 2, 3, 4. 1, 2, 3, 4. So this would be C2H2. And someone who knows organic chemistry knows that, there's got to be some double bonds there because carbon normally bonds 4 times, and now it's only bonding twice. So the name of this guy would indicate that double bond by using a suffix "ene." And in fact, this chemical is called ethene. This one, I don't have to tell the location of this because there is only one option. So I could potentially go, it's in the first carbon-carbon bond. So technically, although this is never done, it'd be 1-ethene. It is located in the first bond. There is only one, so they don't do the one. They just do ethene. Very common chemical used in plastics, all over the place. Now here I have a 3-carbon chain, so this is going to be propene. Now that means a double bond, but where? Well, again, we count from the shortest side. So I count from here to be 1, and then this would be 2. So this would be called 1-propene. But we always count from the shortest side. So technically, I'd always count from the right on this sense. So I'd always have 1-propene. If I drew it this way, carbon, double bond, carbon, carbon, again, I'd count from this side. 1, 2. You always count from the shortest side, meaning the side that gives you the smallest number. So again, we only really call it propene. You could call it 1-propene if you'd like. But again, people don't generally, because it really is only one option. Unless I had 2 double bonds there, that'd be 1, propadiene. But again, that's a different question, a little more complicated. Now here, I would count from the shortest side, 1, 2, and 3. So there's an option. I'm going to call this 1-butene. I could have a chemical looking like this: carbon, 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 put the double bond in the middle. This would be, I'd count from the shortest side. So whether I went 1, 2, 3, or 1, 2, 3, this is still going to be 2-butene. Okay. Now again, if it's on the 1 location, it could be on either side. You should see in your mind's eye that's the same chemical. I could just flip it around, it'd be the same chemical regardless of what side it's on. So we'd never call it 3-butene because we count from the shortest end, which would always be 1. Otherwise, this is your basic idea of how to name a chemical. Every chemical has a name, every chemical has a formula. A couple of these I might just write the formula out for. This guy would be C 1, 2, 3, 4, and then H, and then how many H's? Well, we'd have 1, 2, 3, because that's 4 now, 5, 6, 7, 8, 9. Let's recount that to make sure I'm right. From the left side here, this side here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. C4H9. Alright. You could also write this. I'm going to give myself a little more room. Okay. Another way, a common way to write this would be like this. CH3, CH2, CH, and then CH2. With this type of structural formula, we would be able to give a little bit more better representation of what my formula might be. For this guy, again, I can get this structure. But with this name, or formula, I don't really know where that double bond is located. So, different things accomplish different things. Thank you.